Okay, so in 10.3, number 39, it says a rectangular field is 4 times as long as it is wide. Okay, so you have a rectangular field, and it says it's 4 times as long as it is wide. So if this is the width, then the length has to be represented by 4 times the width, right? So it's 4 times as long as it is wide. If the perimeter of the field is 500 yards, what are the field's dimensions? Okay, so again, 4 times as long as it is wide. Any questions on how we got that W and 4W? So then perimeter tells us that we're supposed to do what? Add all the sides. Right, and since it's rectangular, if this side is W, then this side's also W. And if this side is 4W, then this side is also 4W. So if you add up all the sides, W plus 4W plus W plus 4W, then it should equal 500. Okay, so adding this all up, we have 8, 9, 10W equals 500. Divide both sides by 10, and W equals 50 yards. And so then to find the other dimension, you plug 50 into 4W, which gives you 200 yards. So your dimensions are 50 yards by 200 yards. Any further questions on something like that? And then number 41. It says an American football field is a rectangle with a perimeter of 1,040 feet. So we have an American football field, which is a rectangle, and the perimeter is 1,040 feet. The length is 200 feet more than the width. Okay, so again, they've given it to us in terms of the width. So if this is the width, then the length is 200 feet more than the width. So more than is what operation? Plus, right, or addition. So 200 feet more than the width is your length. It says find the width and length of the rectangular field. Okay, so similar to the other problem, if one side is 200 plus W, then so is the other. And if one side is W, then so is the opposite side. And then add all of these up. And it should equal 1040. So we've got 1, 2, 3, 4W plus 400, which equals 1040. Subtract 400 from both sides, and 4W equals 640. Divide both sides by 4, and W equals 160. Is that correct? All right, so the width is 160 feet, and then the length is 200 feet more than the width. So add 200 to this, and we get a length of 360 feet. And so your dimensions are 160 feet by 360 feet. Okay, so we did perimeter in 10.3, so now we're moving on to area and circumference. So the area of a rectangle and a square, most of you guys are familiar with that one. So on your handout, you have most of the information, but what you're missing are the actual formulas on there. So the rectangle has a length and a width, and so the area is equal to length times width. Good. That's the one I hope that you guys already knew. So if you have a square and say that that square has a side that's labeled with an S, it's also a length times a width, really, but since it's S times S, then that gives you A equals S squared. Hence where that word comes from, square. Okay? So we talked about those square units before already, and how you can split up a rectangle into so many square units, and so on. Now, again, you're going to be given irregular shapes where you have to find the area of those irregular shapes. And the best way to do that is to split it up into shapes that you know. Now, there's a couple different ways that you can split this up. Now, one reason you might be looking for the area of this shape is saying you want to cover this path with bricks. Because you're covering the path with bricks, it's the inside part, right, what you're doing, then that's area. So you have to think about what type of problem, what does it ask you to do, the inside. It's not asking you to make a border around the path. If you were doing a border around the path, then that would be perimeter. So think about those types of problems and what you're getting. Okay, so finding the area of the path, we can do so by splitting this up into two rectangles. Again, you have two ways that you can split this up. So I did it one way. Doesn't matter if you do it a different way. So I went ahead and split it vertically like that. So I have a rectangle that measures 3 by 13. But I also have a rectangle that has one side that's 3 and a partial side of 6. Right, so you're going to have to do some extra work to find that entire side. Now let's focus on the one that we know all the sides of, that top one. To find the area, all we're doing is multiplying. So 3 times 13, 39 square feet. Okay, notice that we have square units now. We've talked about square units, but we didn't really talk about why they're square units. So when you're multiplying in an area, you have a unit times a unit. So feet times feet is going to give you those square units. So make sure that if you're giving an answer for area, that your answer always has the square units on there. Okay, so now looking at the other rectangle, the one on the right, using the information from the other side, we know that that distance is 3 feet. And we already knew that the remaining distance was 6 feet. So 3 plus 6, 9. Okay, so the way I've written it is that I just put it in parentheses, 6 plus 3. Okay, so I knew I had to add those first. 6 plus 3 giving me 9. So 3 times 9 is 27 square feet. So now I have two answers. What do I do with them? Add them. Good. Okay, so adding them together, we get 66 square feet. Now, it's not always going to be rectangles. It might be a rectangle and a triangle. It might, it's any two shapes that you can split it up into. So let's talk about these other formulas then, just to jog your memory there. So a parallelogram. Remember that this is when you take that rectangle and you tilt it slanted. And so we label the height and the base. So the base is just one of the sides, and the height has to be the distance that's perpendicular. Okay, perpendicular meaning that it forms a right angle to that base. So the perpendicular distance from one side to the opposite side is your height. And your formula is just base times height. Now the reason that this formula works, if you think about the rectangle one that you're very familiar with, if you were to form a rectangle right here, we'll notice that this missing piece here is actually the same as this missing piece over, or this piece over here. And it's as if you could cut that off and shift it over to the other side and form a rectangle. So notice that this would be the width of the rectangle, and then this over here would be that whole length of the rectangle. So that's why they knew they had to get that perpendicular distance going up, because it relates to that length times width. Okay, here you have a parallelogram. Assuming that the 8 is the entire base, and so the 4 is the height. And so what do you do with these numbers? Multiply. So 8 times 4? 32. So don't forget the units. So we got square centimeters. But just be careful, because your problem might have a whole bunch of other numbers here. You know, might have 12 and 8. And just make sure that you are looking at the correct numbers that you need for your picture. Now, let's say, so let me change the picture here. Let's say that the 8 only measured this piece, and you knew that this side over here was 5. Okay, so you need the entire base times the height. So what can you do? Pythagorean theorem, good, because notice that you have a right triangle over here. Okay, right triangle. Which part of the triangle were you given? The hypotenuse and a leg. Okay, and you will have problems in your homework where it will give you missing information like this, where you might have to use something you learned from a previous section. Okay, so we can say that 4 is A. We don't know what B is, and 5 has to be C. So 16 plus b squared equals 25. Subtract 16 from both sides. B squared equals 9. And so taking the square root of both sides, b equals 3. Okay, so that tells you that this piece right here is 3. And so now what numbers do you need to multiply together? Okay, 3 plus 8 is 11. Good. So you have 4 times 11, because the entire base measures 11 centimeters. So everybody okay if you're blending formulas together? So that equals 11, and your area would be 4 times 11, or 44 square centimeters. Okay, area of a triangle. A lot of you guys remember your formula for area of a triangle, but here's one way that you can sort of understand where the formula comes from. If I were to copy this triangle and flip it over this way, okay, copy the triangle, flip it over, this is the shape I would create. What shape do you have? The whole thing, both triangles together. Parallelogram. And we just learned that the formula for area of a parallelogram was base times height. Okay, so this parallelogram is made up of 2 equal triangles, so how much, if we're only looking for the triangle in white, how much of that parallelogram do we need? How much? Half, thank you. Okay, so that's where that formula of a triangle comes from. It's 1/2 base times the height, because it's half of a parallelogram if you flip those triangles and duplicate it. Okay, 1/2 base times height. So here's your triangle. So let's say that 16 goes from here to here. So what's our base? 16, easy question. Come on, participate. Height? 10. Okay, so we have a base of 16 and a height of 10, so substituting it into your formula, you do have to multiply, but don't forget that you have that half in there. Okay, so hopefully you get 80 square meters. Lots of ways you can put this into your calculator, by the way, if you tend to fumble with the buttons. You know, you can do 16 times 10 divided by 2, or 1 divided by 2 times 16 times 10. Okay, however you want to put that in, it works. Now again, you may have a problem where 16 doesn't measure the entire base, it only measures this part, and they might have you use Pythagorean theorem or something to find a missing side. So be paying attention for that type of stuff. Okay, trapezoid. Now notice that we've labeled two sides. You always need the numbers from the two sides that are parallel to each other. The sides that aren't parallel, you don't need that at all. So the parallel sides, which we call both of them bases, and the perpendicular distance between those sides. So your formula is area equals 1/2 times height times the quantity of A plus B. So you have to add those bases first, then multiply it times the height, and take half of it. Okay, so here's your diagram. Make sure to choose the appropriate numbers and substitute it into your formula. So which numbers are not needed for this problem? 17 and 19, good. So we do not need these to find the area. Again, assuming that 46 is the entire base. Okay, so the height is 13, the long base is 46, and the short base is 32. And we don't use the 17 and the 19. So substituting it into our formula, we have 1/2 times 13, and in parentheses, 46 plus 32. So again, don't forget order of operations. Do what's inside parentheses first. So when you add and then multiply it all together, what do you get? Okay, 107. Wait, 507, sorry, thank you. Okay, so 507 square feet because you multiplied feet times feet. So remember, area is always square units. Now again, if 46 had not been the entire base, then the 17 is very important because you have to use that 17 and the 13 with Pythagorean theorem. You have to find that missing piece right there so that you can then put that into your formula. Okay, so 10.4. So in here it's going to give you some normal polygons where you have to just find the area based on the formula you have. So what do I do here? Okay, 8 times 3, giving you 24 square meters. Okay, well done. Okay, so here they have a triangle, and your triangle itself is the blue shape. But notice that they extended the base with these dotted lines and so on. Now, the reason they had to do that is because you need the perpendicular height from the base to the other vertex of the triangle. So in order to figure out what that height was, you have to extend this line and draw that perpendicular straight down. So to find the area, which numbers do we need in our formula? So first of all, here's our formula. We know, okay, so I just sort of gave away the height. The height is the 1.8. Okay, that's the height from the top tip to the bottom. So therefore, what's the other side that we need to use here? Then 9.8 is correct, because the base of the triangle that you needed could have been any one of these sides, but if you already have a height drawn, then the base that you're using has to be the one that this height is perpendicular to. Okay, so plugging that in, you have 1/2 times 9.8 times 1.8. It says type an exact answer, so that means don't round. Whatever you get in your calculator, type it in. So what is 1.8 times 9.8 divided by 2? What'd you get? 8.82. Everybody agrees? Okay, 8.82. Fantastic. Okay, I want to point out the irregular shapes that you have to find the area of. One in particular. Okay, like this one. Sort of looks like the side of a house. And there are actually two ways that you can do this problem. Now, when it's not a typical shape that you're used to seeing as far as the area formulas, we didn't get an area formula for a pentagon. So instead, you have to split this up into shapes that you do know. So what do you see?
Rectangle and a triangle.
Okay, that's what most students see. So a rectangle and a triangle. So that's what we'll go with. There is another way to look at it, and I can point that out. But okay, so we need to find the area of the rectangle and the area of the triangle. So the rectangle is a little easier. We have a length and a width, so 14 times 34 gives us, say it again, 4,006? 476, okay. Everybody agree? All right, so now with the triangle, we need some information here. We need a base and a height. So what's the base? 34 is correct if you use this base right here, so that's 34. And then the height would be this distance here. How can you figure that out? 21 minus 14 is correct. So notice that the side of the house is 14, but the distance from the ground to the top of the roof is 21. So subtract, and you get 7. So that means that this distance here is 7. Yes, question? That's what the other option is. So there is another. It's not necessarily easier. It's just another way to do it. Because the formula is more complicated. But yeah, I'll show you that cutting it that way in a second. So when you multiply this together, what do you get? 1, say it a little louder. 238. Everybody agree? Oh, dividing it by 2. So this is 34 times 7. Okay, divide by 2 and you get 119. Okay, so now add your rectangle plus your triangle. And your final answer is? $595. Give me the digits. 595. Okay. All right, so typing in 595. Good job. Okay, so the other way that you could have looked at this is if you slice it down the middle Notice that you have two equal trapezoids. And so you need this space, and then the perpendicular height between them, which is half of 34. Plugging it into the formula, you have two equal ones, so you find the area of one trapezoid and multiply it by 2, and you have your area. It's however you see it. That's what's easiest. If you don't see two trapezoids, then it's not easier to do it that way. It's easier to do a rectangle and a triangle. So a circle is a set of points in the plane equally distant from a given point, its center. So if you start with just any point, okay, saying that that's the center, and then we go a certain distance, and so all of these points, more or less, represent the circle, because it's all the points that are the same distance from that center. The center is not actually part of the circle, but you need that center as a reference point to define the points that are on that circle. The radius is a line segment from the center to any point on the circle. Okay, so that dashed line that I already created, that distance from that point to the center, that is your radius, and we're going to call it R. The diameter is the line segment through the center whose endpoints are on the circle. In other words, the diameter has to go all the way across. And so that blue line there would be the diameter. So on your handout, you should have those pictures. All right, so notice the comparison between the radius and the diameter. What do you guys observe there? Okay, the diameter is 2 times the radius. Good. So we could create a formula right there that the diameter is equal to 2 times the radius. So if you were given the radius, but you need the diameter, you just need to double it. In the same respect, how can we compare the radius to the diameter? Instead of the diameter being 2 times the radius, we can also say that the radius is half the diameter. Okay, so however you need to look at it, if you're given the diameter and you need to find the radius, then just take half of it to go back to your radius. All right, when we have a circle, we don't call it perimeter when we're going around the circle. Instead, we call that the circumference. And so the circumference, which we're going to call capital C, of a circle with diameter D and radius R. Now, there's 2 ways that you can work out this formula. If you are given the diameter, well, then you just need to use this formula right here. The circumference equals pi times D. If you are given the radius, well, since the radius is half of the diameter, multiply that by 2 and then multiply by pi. So 2 pi r is another way to look at it. Okay, so this introduces a new character called pi, this Greek letter, and it stands for 3.1415 and so on. It's an irrational number that goes on forever. And I don't remember if I put it in your announcements. Did I wish you a happy Pi Day last Thursday? Okay, last Thursday was Pi Day. Does anybody know why it was last Thursday? March 14th. Okay, we usually abbreviate pi as 3.14. So it's approximately 3.14. So hence, somebody decided, oh, look, March 14th is 3/14. So let's designate that as Pi Day. Okay. All right, so sometimes you're going to be asked to round to 3.14. Sometimes you're going to be asked to use the pi button in your calculator to have a most exact answer as possible. So you just need to pay attention to what the instructions tell you in Math Excel or in your homework. Sometimes it doesn't specify. So if it were on a test and I don't specify and it's a show your work problem, well, then you would just tell me what you're using. Are you using the pi button or are you using 3.14? You would show me that on a test and then I would know. Okay, so circumference, one of those two formulas. If you're looking for area, for the area you have to use the radius, and there's one formula of pi r squared. Okay, so the cheesy joke is pi's r squared. I thought they were round. Okay, so didn't you know? And so make sure that if you're given the diameter, you first look for the radius. Order of operations is important in that formula. You have to square the radius first and then multiply by pi. Okay, so here's an example of a circle. What information are you given here? Diameter, because it's all the way across. And so you need to find the circle's circumference, given that the diameter is 40 yards. So in this case, since we're given diameter, you can use the formula that has diameter in it. And so I use pi times d. This time, we rounded to 3.14, and 3.14 times 40 is 126 yards. Now, this didn't actually come out exactly as 126 yards. This PowerPoint rounds when it doesn't ask to, so I just wanted to double check that and show that to you. So this actually technically came out to 125.6, sorry. So this comes out to 125.6, which rounded to 126. Now, technically, we should use an approximately equal on both of these answers because we've already approximated pi to 3.14. Now, the problem could ask you a couple different ways on how to show your answer. If it asks you to put it in terms of pi, then when you substitute into your formula, what that means is that you're not going to multiply out the pi. You're going to treat it like it's a variable and just leave it in there, like if it was 40x. As your answer. So if it asks you to leave it in terms of pi, that's what it means. Now in Math Excel, it already has the pi written there. You just have to type the coefficient. So in this case, you would just type the 40 in the box for your answer. Now, let's say that it wants you to use the pi button, or it doesn't tell you to use 3.14. You should probably assume that it wants the pi button in your calculator because that means it wants you to get the most exact answer possible. So if you do 40 times pi in your calculator, you would end up getting, okay, so 40 times the pi button in your calculator, you get 125.663 and so on. Now notice the difference in the answers. If I asked you to round to the nearest whole number, then you would get the same answer as what we did with 3.14. So it would be approximately 126 yards. If I asked you to round to the nearest tenth, you would get a different answer than with 3.14. Because notice for the first one, we got 125.6. For the second one, notice that rounding to the nearest tenth would bring us up to seeing how the answers look. And just the more I stress about doing your homework before doing the quiz, because the homework will give you an idea of what you're supposed to be typing in, and you can correct it right there if there's a minor mistake. Whereas in the quiz, you won't know till you submit the quiz, and then you have to do the quiz all over again if you want a better grade. Okay, so again, I can't stress enough to get your homework done as soon as you can so that you have that opportunity to do the quiz with all that information given. No, you can, it just depends on the calculator, how you have to type it in. Most calculators nowadays, you can just put 40 and then the pi button and hit equals, and it knows that you're supposed to multiply. But again, it's up to your calculator, so make sure you're testing that out. Here's an application problem. It says, which of the following is a better buy? A large pizza with a 16-inch diameter, or for $15, or a medium pizza with an 8-inch diameter for $7.50. So most of the time I bring up this problem, students sort of just glance at it and think, that seems the same to me. But let's go ahead and examine it further to see if it is. So we have a 16-inch pizza. That's the diameter. And sometimes when you're in a pizza place, it actually shows you the pan and it measures out the diameter for you. And this one is $15. And then you have an 8-inch pizza for $7.50. All right, so it's half the diameter of the other one, so half the price. We can see if that's comparable. So first of all, you have to figure out which formula are you using, circumference or area. Well, think about it this way. Are you just going to eat the crust, or are you going to eat the entire pizza that's in the inside? You want to eat the inside part, right? I don't know anybody that just eats. I know people that don't eat the crust, but I don't know if I know anybody that just eats the crust. But okay, so we want area of the pizza because we want the inside part of that pizza. So working out area for each one here, that formula is pi r squared. But we were given the diameter, and for area we need the radius. So for the first one, radius is 8, good, because it's half of the diameter. And in the smaller one, radius is 4. Okay, so substituting in, we have pi times 8 squared, which is 64 pi. And then let's just use 3.14 for our purposes here. So we have 64 times 3.14, which gives us 200.96. And these are inches squared, because we're in area now. So remember that area is units squared. So go ahead and work out the area for the second one. Okay, so you get 4 squared, which is 16 pi. And so hopefully you got 50.24. All right, so now it wants you to find the better buy. So we've done these problems before in this class. If you're looking for the better buy or the better value, then you need to get it down to price per unit. All right, so that means price per unit. And that tells us, okay, the per tells us we're going to take the price and divide it by the units. So price per unit just tells you what to do. So off to the side here, we've got a price of $15 divided by the units, which is 200.96, divided by that area. So we get 0.074. Really 0.075 if I'm going to round, but just I put the first 3 digits there after the decimal. Over here, if we take price per unit, so we have $7.50 divided by 50.24. Good, so 0.149 dot dot dot. Okay, remember that we're talking about money here. This now gives us the price per square inch. That's the units that we were working in. So in the first one, if this is money, think 2 decimal places. So this is really 7 cents per square inch. And so this one over here is, if you round up, round, we've got 15 cents per square inch. So which one's the better buy? The 7 cents, right, the larger pizza. So notice that if you think, oh, the diameter is half of the original and half the price seems like a good deal. Well, so really, you're paying double, more than double, because one's 7 cents per square inch, the other one's 15 cents per square inch. You're paying more than double if you order a smaller one. You might say, oh, let's order 2 smaller ones instead of a larger one. And, you're paying more than double than what you had to. You're not getting as much pizza either. So notice in the large one, you're getting 200 square inches, and in the smaller one, you're getting 50 square inches. So does 2 smaller pizzas add up to the larger one? No, that's only half, right? 2 smaller pizzas. So, again, some of the things to consider, this is what businesses do. It's a marketing ploy, okay, to make you think that you're getting, a comparable price. Now, if you're only going to eat as much as an 8-inch pizza and the rest of it's going to go to waste, well, then, of course, you only want to spend $7.50 and not $15 and, waste the other half the pizza. But if you're looking to purchase a good amount of pizza, then that larger one is a better buy. All right, so for this particular problem, it wants you to find the circumference and the area of the circle. It wants you to first express the answers in terms of pi and then round it to the nearest tenth. Notice it does not tell you whether you should use 3.14 or pi, in your calculator. So first of all, what information did they give us? The radius. So we have a radius of 6 centimeters. And the first thing it wants us to look for is circumference. So what formula might be the easiest then to use? 2 pi r, good. Because we're given the radius. So substituting that in, we have 2 times pi times 6. And so in terms of pi, what do we got? 12 pi. Just multiply the numbers together. So 2 times 6 is 12. Leave pi in your answer as if it was a variable there. So for your first answer, you're just typing in the number 12 because the pi is already there. I've seen so many students mess this up and they don't get full credit because they're not paying attention to what they're supposed to be typing in. All right, so for the first one, type in 12. Well done. Now it wants you to round it to the nearest tenth. So now you're going to take 12. And let's see what the calculator has in Math Excel. If I pull up the calculator, I don't see a pi button. So if we just type in 12 times 3.14, since there is not a pi button on here, then we get 37.68. And then if I use my calculator that does have a pi button on there, 12 times pi gives me 37.699. So if I'm rounding to the nearest tenth, am I going to have a different answer? You're still only rounding to this digit here. So you get 37.7. Either way you work it out. So here we get 37.7 as well. So it doesn't really matter in this case. You get the same answer. You get 37.7. Excellent. Notice the nice thing about the calculator in Math Excel is that it stays on your screen even though you go to click. If you'd opened up the calculator on your computer, then it would disappear every time you click on the window for Math Excel. That's the nice thing about that calculator. Now we need to work out the area. So formula for area is pi r squared, and we were given the radius, so putting in pi times 6 squared. In terms of pi, all we have to do is square the radius. So we get 36 pi centimeters squared. But the pi and the centimeter square are already there. So just type in the 36. Well done. So now it wants you to take that area and round it to the nearest tenth. So this calculator, do 36 times 3.14. And we have 4259. That seems a little big. I think I didn't clear my calculator. Okay, so 36 times... Yeah, I did the first time. Okay, so 36 times 3.14. Okay, that's better. Or 36 pi. So this one would give you a different answer because in your calculator for pi, you get 113.09 ... Okay, so rounding to the nearest tenth in the calculator, that would give me 113.0. And if I use the one with the pi button, I get 113.1. Okay, so there are some problems in Math Excel that it'll accept both answers. And so sometimes you won't quite know what it's looking for because it's accepting either one. But you want to test that out. So let's go ahead and just put 113.0 and see what happens. And by the way, if it asks you to round to the nearest tenth and it didn't terminate at 113, you really should put 0.0 to show that that's what you rounded to. Fantastic. Okay. I'm going to guess that on this problem it may have accepted both answers. It was one of those problems where it worked it out since it didn't specify.
I saw that, like, one time I answered it, had, like, multiple answers, possible answers.
Right. When you go back and you check your work, then and you put your cursor on the answer, it'll show you all the different answers it could have been. So if I exit out, let's save this, and then go back to question 8. It may not show me the answers because I got it right. But if you got it wrong, it would show you, if it showed you more than one answer, then that's because there was more than one answer that could have been put in there. All right, let's take a look at something like this. It wants you to find the area of this figure. Express the answers in terms of pi and then round to the nearest tenth. So notice that it tells us that that middle figure is a square. And then it has 4 semicircles around it. So in these pictures, you can assume that the edge of the other figure is the diameter of that semicircle. All right, so in this square, notice that this side is measured as 4 centimeters. So let's do one piece at a time. Let's first do the area of the square. And so since the side is equal to 4, then what do I do with that 4? No, we're just doing the area of the square. 4 times 4, right, or 4 squared, which equals 16 square centimeters. So that's the area of the square. That's why I put a little s there to show that that's the area of the square. This piece right in here is 16 square centimeters. All right, now let's take a look at these semicircles. Even though we have 4 semicircles, if we sort of piece them together, then how many circles do we have? 2. I think it's easier to look at it that way because your formula is for an entire circle. All right, so all of these right here make up 2 circles. So let's do area of one circle, which is pi r squared. We need the radius. This is 4 centimeters, which I mentioned that's the diameter because it goes all the way across. So therefore, the radius is 2 centimeters. Good, half of the 4. So plugging this in, we have pi times 2 squared, which gives us 4 pi. And remember that they wanted it in terms of pi to start out with. Now this is just one circle, so what do I have to do to this answer? Double it, good. So multiply by 2 and we get 8 pi. All right, so for both circles, the area is 8 pi. What are you supposed to do with these 2 areas now for the area of the entire picture? Nope. Add them together. So you got a square plus all of these semicircles. So the total area is 16 plus 8 pi. These are not like terms because they don't have a pi. They don't both have a pi in them, so you can't add these numbers together. Yes? 16 was the area of the square. So you take the square and add it to the area that you got from all those semicircles, and that's the total area. So it's all of this centimeters squared. Okay, now first, that's our first answer because it wanted it in terms of pi. So that's how you type it in, because you can't add a 16 with an 8 pi. They don't both have a pi. It's like adding a 16 plus an 8x. You can't add those 2 numbers together because they don't both have an x in them. So same concept here. So that's our first answer. Any other questions in regards to that? Okay, so the rest of it's going to disappear. Everybody saw all the formula part. So in this box, we are typing in 16 plus 8 pi, and the pi button's in your palette right here. Okay, 16 plus 8 pi, that's in terms of pi, centimeters squared. Now I want your answer rounded to the nearest tenth. So now we're going to go ahead and multiply out what pi is. And again, there's 2 ways we can do this. We can use 3.14 or we can use the pi button in our calculator. Okay, if we do 16 and use the pi button, 16 plus 8 pi in our calculator. Order of operations says do 8 times pi first and then add the 16. So we get approximately 41.13 ... If we do 16 plus 8 times 3.14, well, 8 times 3.14 is 25.12. So plus 16 gives us 41.12. So if we're rounding to the nearest tenth, are we going to have the same answer or different answers here? The same, okay, because the number after the 1 is less than 5. So we get approximately 41.1 square centimeters. If you're using 3.14, you have replaced pi with 3.14. You've substituted that value in. just like you would substitute for a variable. All right, so typing in 41.1. Excellent. Okay, in this problem, it wants you to find the area of the shaded region in terms of pi. All right, so notice that you have one large circle, and then you have two smaller circles inside of that. And it shows you that the radius of each of the two smaller circles is 4 centimeters. So think about, in words, what procedure do you have to take to solve this problem? Find the area of the two smaller circles and subtract it from the area of the larger circle. Good. And so you're doing area of the larger circle minus area of two smaller circles. Okay, so that's the bigger picture of what you're doing. And then, so now you have to do all of these parts to this bigger picture. So let's go ahead and start with the smaller circles here. So remember that area is equal to pi r squared. Did they give us the radius? Yes, and that radius was 4. And so substituting this in, we have pi times 4 squared, which equals 16 pi, but that's just one of the circles. So to get both of the circles, I just want to double it. Good, times 2. So then multiplying your numbers together, you get 32 pi. And since it's centimeters, this gives us centimeters squared. Okay, so this is the amount that we're taking away, the area of the two smaller circles right here. So we have 32 centimeters squared that's being taken away from that larger circle. Any questions on how we found that area? So now let's find the area of the larger circle. Now, the radius is not drawn in this picture. So you have to use the information that you're seeing here. And what if I go ahead and draw a line all the way across right here? Okay, if I draw that diameter going all the way across, what does that tell you about the radius of the larger circle? 8, because well, no, the radius. I had asked for the radius. So, yeah, the radius would only be halfway here. So if this piece is 4 from here to here, then that means that this piece is 4. Notice that it's the diameter of the smaller circle. The diameter of the smaller circle is the radius of the larger circle. So the radius of that larger circle is 8. So substituting that in, we have 8 squared, which is going to give us 64 pi centimeters squared. Okay, so that larger circle is, oh, I just realized I missed something on this red, what I wrote here. What did I forget? On the 32 centimeters squared, the pi. Okay, circles is pi centimeters squared. Now, since they both have a pi in their answer, we can go ahead and subtract these numbers. So 64 pi minus 32 pi is 32 pi square centimeters. Okay, 64 minus 32 is 32. And that is our final answer. So that is how much that shaded area is equal to. Okay, so typing this in, don't forget the pi because it's not written there already. So 32 pi is your answer. Nice work. So you want to make sure that you're paying attention to when pi is already there in the answer box and when it's not.